Interactive mathematical notebook for mathematics of quantum fluctuation in relation to the inflationary multiverse. We have the equations. So this is one of the most famous and foundational equation in physics, specifically in quantum field theory. So we have these equations, and we have this one, the term here. So this is a field that exists everywhere in the space and time. So this symbol means a small disturbance or fluctuation in that field. So think of a calm lake. The lake surface, the background field, so the ripples here, which is the ripples. And we have the integral here. So the integral of this one. So this means add together waves having every possible wavelength and directions. Then we have this triple. We have the uh, cube of the derivative of p here. It means integrate over all three momentum components. So our key here refers to k sub x, k sub y, and k sub z. And we have the factor, the dou pi cube here. So it is a normalization factor used in a Fourier transform. So what is k? So k is the wave vector. So it tells us wavelength, directions, momentum. So we have p equal to h bar k. So a large k means short wavelength, high momentum, and a small k long wavelength and low momentum. Then we have the exponential here. So this one exponential. So e to the kx here. It represents a wave. More precisely, this is e to the kx minus angular velocity times the time. So it describes a wave traveling in one direction. Similarly, this is a wave traveling in opposite directions. So what is E sub k here and E sub k dagger? So these are called the annihilation operators. So they remove one quantum particle from the field. If there is one particle, we have the kit of one, uh, E sub k, kit of one equal to zero. So there are no particles, uh, the kit of A sub p is equal to zero. So that is equal to zero. So if the dagger here, if there is the creation operator, it creates a particle. For example, A sub k dagger, kit of zero here is equal to one. So A sub k here destroys a particle, and a dagger sub k creates a one. So why are both terms needed? Uh, a real scalar field must be Hermitian. That is, phi of dagger is equal to phi. So to satisfy the property, both positive and negative frequency components are included. AK times e to the ikx and e sub dagger times e to the negative ikx. Together, they ensure the field corresponds to a real physical uh, observable. So we have the physical interpretations. Imagine plucking a guitar string. So the vibration can be written as a sum of many sine waves. Similarly, uh, this delta phi of x of t is written as a sum of infinitely many planes waves. So each wave corresponds to a possible quantum particle. So instead of vibrating string, quantum field theory describes vibrating fields. So every particle is one quantum of these fields vibrations. So in particle physics, for electromagnetic field, photons are the quanta. For the electron field, electrons are the quanta. For the Higgs field, Higgs bosons are the quanta. Each momentum mode K has its own creation and annihilation operators. So in cosmology, the equation is extremely important. So during cosmic inflation, the inflation field experiences tiny quantum field fluctuations. So this delta phi of x of t, these fluctuations are expanded exactly in the way in this way. So the quantum fluctuation later become density fluctuations, galaxy clusters, and ultimately the large scale structure of the universe.